Welcome, everyone. This is an introduction to Protocols.io. My name is Gabriel Gasque, and I am Head of Outreach. And before we start this presentation, let me tell you a little bit about myself. So I have a background in experimental neuroscience with doctoral studies and postdoctoral training. And before joining Protocols.io as Head of Outreach, I was an editor in PLOS Biology, the flagship journal of the Public Library of Science. So I consider myself a scientist as well as an advocate for open science, experimental reproducibility, and research integrity. I would also like to share some housekeeping information with you before we delve into the main content of the presentation. As mentioned before, I am recording the webinar, and I will be sharing the recording and the slide deck with all registered participants. Also, closed captioning has been enabled, so feel free to turn it on if you want to use it. I will speak for some 40 to 45 minutes, leaving at the end some time for questions. But you can start typing those questions right away in the chat or in the Q&A window of Zoom. Finally, well, this is an introduction to Protocols.io. You can find upcoming, more advanced webinars by visiting protocols.io/webinars, which is one of the URLs at the bottom of this slide. In the second URL, you can request at any time a one-to-one demo. To do that, you have to go to protocols.io/help/demo. Now, this is the agenda for today's presentation. I will go over some of the more general points in the terms of motivations for creating Protocols.io, what our mission is, and how our platform and tools can make your work easier and faster, both in the research lab and in the classroom, as well as to increase reproducibility both inside and outside your own research group. But let's begin with what Protocols.io is. So Protocols.io is a virtual platform for the collaborative development, sharing, and publication of detailed, up-to-date, and reproducible research protocols before, during, and after publication of a research article. Protocols.io was launched in 2014. We currently have over 210,000 registered users who have created and published over 22,000 public protocols and over 82,000 private protocols. These private protocols are not published. The public protocols are all open access, which means they are fully searchable and they are free to read, use, and reuse. Last year alone, these 22,000 public protocols had over 3 million readers. And to set the background on why Protocols.io is important, we have collected a series of tweets that comment on the difficulties and frustrations of trying to replicate previously published experiment. And as you can read in this example, Daniel goes from reference to reference, trying to understand how certain devices used in a paper from 2017 were fabricated. And when he finally reaches the original publication from 2009, it simply says, devices were fabricated with conventional methods. This is just an example that highlights a widespread problem. That is very often the information reported or included in the materials and methods sections of published articles is insufficient to allow readers to understand what was done and to reproduce the experiments. As part of the background on why we created Protocols.io, we also like to talk about the Cancer Biology Reproducibility Project, which was a $1.5 million initiative coordinated by the Center for Open Science and by Science Exchange, with the goal of trying to independently replicate almost 200 experiments from about 50 high-profile papers on cancer biology. What the Reproducibility Project researchers discovered very soon after the project began is that it is very difficult to replicate previously published work. There are several reasons why this is the case, but one of them is that the original researchers didn't document in their articles with enough detail what they did and how they did it. So what you see on the screen now is the Center for Open Science website that summarizes some of the results of the Cancer Biology Reproducibility Project. And as you can see, of the 193 experiments that they tried to replicate from these 53 articles, 0% of the protocols were completely described. 0%, which made it impossible to reproduce them without contacting the original authors. But equally striking, when researchers from the Reproducibility Project contacted the original authors, they also discovered that these did not always could tell how exactly their own experiments had been done. Therefore, the problem of lack of reproducibility goes beyond the lack of adequate reporting in published articles, but also highlights deficiency in the way researchers keep record of their own research protocols for housekeeping. And this is caused, among other reasons, because people move from labs. So students graduate and leave, postdoctoral researchers become faculty elsewhere, and so on. And traditional paper notebooks can be easily damaged, misplaced, and lost, and are difficult to search to find the most up-to-date version of a protocol. Therefore, we thought that a cloud-based system for the proper preservation and publication of detailed research protocols was needed. So generally speaking, Protocols.io comes in two flavors. We have a completely free open access repository, which provides unlimited publishing of protocols. Each of these public protocols will receive a unique digital object identifier, or DOI, making them permanent and citable. It is thus free to create an account in Protocols.io and to publish an unlimited number of protocols. And because the repository is open access, it is equally free to come and read, use, and reuse any of these public protocols. But we also have premium accounts that offer everything the free plan offers, plus an unlimited number of private protocols and private workspaces, premium training, and for the institutional accounts, a free protocol import service. So if you're interested to learn more about our plans, you can find more details at protocols.io/plans/academia. And in a few minutes, I will explain what workspaces are, which I have mentioned, and I will tell you about the protocol import service. Some of you present here might already have an institutional account if your university or research center is a partner of protocols.io. You can check that by going to protocols.io/for-institution, and as I show you in this movie, scroll down that page, check if your organization already has premium access, and then you can see if your organization is listed here. If that is the case, you have a premium account of protocols.io. But let's now discuss why it is productive, time-saving, and rewarding to create, share, and publish detailed experimental protocols, in addition to fostering reproducibility. The key message that I want to convey is that practicing open science, and in this case open methods, is beneficial for the practitioner as much as it is for the extended research community. But let me begin by showing how the protocols created and published in protocols.io go beyond what a traditional static PDF offers. These protocols are live, dynamic, and interactive, yet persistent and citable documents. So I'm going to be opening one of these protocols by following this link. And because the protocol has been published, it has an assigned DOI, making it both permanent and citable. The protocol itself is written in a recipe-like, step-by-step fashion with a lot of detail. The protocol can be supplemented with images, pictures, tables, and even videos that you can play while running the protocol if there are steps that might be complicated to explain with text. Different sections of the protocol can be coded in different colors, creating a table of content that I can navigate. Now, the protocols are interactive because any reader can come, find this plus sign, and add a comment. And the owner, the author of the protocol, will receive a notification, and they can come to the platform and respond to your comment or question. The protocols are versionable as well, and in this case, the authors have created 3 versions of the protocol, and I can navigate between the different versions of the protocol. I can also create my own editable copy or fork, so I can optimize this protocol to adjust it to my own personal needs. And the protocol is also dynamic. I can create a run record of the protocol. So as I run an experiment, I can follow the protocol directly in the computer or tablet. I can mark each step as done as I make progress. I can add a notation or even change the content of a step as I run the protocol without modifying the original protocol. And at the end, I can just save the run record as an independent file by finishing the protocol. And while there's a historical bias in favor of protocols in biomedicine, the platform itself is agnostic to the research topic, and researchers have begun to use it to develop and share and publish protocols beyond the wet molecular lab. So in this slide, I show you 7 examples of protocols in electronics, computational sciences, clinical research, meta review and systematic analysis, environmental sciences, archaeology, and social sciences. And as an example, again, I will show you a protocol in archaeology. This protocol describes a method to create images of lithic tools, prehistoric lithic tools. And again, the protocol is written in a recipe-like step-by-step fashion. It is enriched or supplemented with images, pictures. It has different sections. It is interactive, dynamic. It can be run. I can create my own editable fork. It is versionable. And in fact, this protocol was included in a peer-reviewed paper in the journal PLOS ONE. But let's discuss why we think it is rewarding to create and publish detailed research protocols. Not necessarily in order of importance, but a first advantage of making your methods public is that by using specialized repositories to publish your protocols, you are increasing the chances that your methods will be discovered and reused, which should lead to more credit and recognition. And let me use an example here taken from X, previously known as Twitter. So you can see here a tweet from a researcher who was looking for a protocol for RNA extraction from primary cortical neurons in culture. Someone answered this tweet and recommended a protocol that is in protocols.io. But this protocol is actually part of a paper that was published in the journal GigaScience. Now, interestingly, the paper was about a fish parasite. So the chances of researchers working on primary cortical neurons in culture finding a paper on a fish parasite as a means of finding a method that would work for them seem really slim. But because the protocol was published independently in a specialized repository, it made the method more discoverable and increased the chances of people reusing it. And once a protocol is published, the electronic document has a tab called metrics that shows all the traffic and use of the protocol, including number of views, bookmarks, exports, copies, comments, and citations that the protocol has received. Another reason to make your protocols public is to guarantee preservation and to facilitate seamless continuity of the work inside your research group. As we have discussed, a large fraction of a lab personnel is floating because the students are just there temporarily, they will graduate and leave. Postdoctoral researcher might become faculty elsewhere, and so on. Publishing your protocols makes them persistent, citable objects that will be permanently stored in your workspace as well as in the open access repository. And I should mention that all private and public content in protocols.io is mirrored and backed up in Clocks, GitHub, and the Internet Archive. And public sharing of research protocols also increases the chances of establishing collaborations, as we have seen cases where researchers report that this is the case. And I would like to show you how the common functionality of the platform that I briefly demoed before allows an open, scholarly, and productive discussion between all parties interested in a particular protocol or method. So I'm opening another public protocol. This one is particularly popular. Again, it's a detailed protocol written in a recipe-like step-by-step fashion. But what I want to show you is that this protocol has received over 1,400 comments. And I can click in the comment section and I can see the conversation between the users of the protocol and the authors responding openly to those comments or questions. So this certainly creates an open, scholarly communication that could potentially lead to collaborations. And managing and publishing your protocols should also simplify your work down the road when the time of submitting and publishing a paper comes. I'm going to use another example, again from X. We have here Professor Jonathan Kipnis at the Washington University in the United States tweeting and saying, what if labs publish each of their unique methods protocols and in future papers, instead of rewriting the protocols, we just cite them? And he adds, we waste so much time on methods by saying the same thing differently. And that is exactly what protocols.io is about. You can publish your update detailed research protocols in the open access repository, obtain DOIs, and then anyone, you or your colleagues, can cite those protocols. But citing detailed protocols goes beyond saving time by not rewriting methods. Citing and using detailed protocols improves rigor and reproducibility, making your papers more robust and impactful. And this is what the authors of this PLOS Biology paper did. They created and published their protocols in protocols.io, obtaining a citable DOI, which they then included in the materials and method section, replacing some of the writing. Now, the reader, by following the link, has access to the detailed step-by-step protocol in protocols.io. And a really nice thing about how protocols.io works is that the protocols are versionable, as I mentioned before. So if the authors have updated their protocol since the time of publication of the paper, the reader will be notified that there is a new version, and they can choose to read the protocol as it was published together with the paper, or by following the View the Newer Version link, have access to the most updated version of that protocol. And as a bonus, by practicing open science, and particularly open methods, you increase reproducibility in the field, which is a present, a gift from you to your colleagues and to the extended research community. But you also increase reproducibility within your own research group, which is a present for your future self. And in this push to increase transparency, accountability, and reproducibility, several organizations, including over 500 scientific journals, funding agencies, and educational and research institutions in 3 continents, support and promote the use of protocols.io. Now, let me give you a taste of how the platform looks like and how its different functionality allows you to do everything that I've told you. Organize and preserve your work, collaborate, save time, increase your reproducibility, impact, and credit. So the platform has 3 main sections: the workspaces, the file manager, and the editor. And I will explain in the next few slides how they relate to each other by using a simple cartoon. So the workspace is where everything happens. It is from this space that you create protocols, organize your work, and collaborate with others. The workspace has a folder that is organized by the file manager. And in the file manager, you can use the editor to create protocols. During my explanation on what each of these sections do and how they relate to each other, I will be moving back and forth between them. So, if you go to our website, what you see on the screen now is a landing page. You can create an account if you have not done so already and log in. You can also log in using Orchid, Facebook, or Google. Once you start a session, the system will ask you to create your first workspace, which in this case, I have entitled Research Project 1. On step 2, you can also start inviting colleagues to join your workspace, but step 2 is not compulsory, so you can skip it. Once you create a workspace, you have access to the file manager, which is now empty because in this example, the workspace is new. To the left, you have access to the administration menu of the workspace, and I will demo it in a little bit. And to start creating protocols, you go to the new button to the right. The file manager will eventually contain, display, and organize the protocols you have created within the workspace, as you see in this example. The file manager supports any file type. It helps you archiving, auditing, and exporting because it can connect to Dropbox, OneDrive, and Google Drive. And it has been designed with enterprise-grade security and backup functionality. The editor has detailed components, as I showed you before, a granular editing history, and allow all changes to be reverted if needed. The editor also allows concurrent editing by 2 or more collaborators, the same way that 2 or more people can work simultaneously on a Google document. The protocol itself is written in a step-by-step format, and different sections of the protocol can be coded in different colors, as I showed you before. Now, going back to the workspace, this is the space for collaborations. You can invite anyone to join your workspace. It can be a student or postdoc in your same lab. It can be another faculty member within the same institution, or even external collaborators. To invite collaborators to join your workspace, you go to the administration menu of the workspace, select Manage Members, and then you can start inviting colleagues to join your workspace by typing their email address. They will have to create an account in protocols.io to join your workspace, but creating accounts is completely free. So there is no barrier for them to join your workspace. You can make your workspace public, meaning that it will be searchable, and people who find it can request to join, or you can make it private, which is the default setting. You can also manage the privileges, the permissions that the colleagues that you have invited to join your workspace will have, and you can limit what they can do, such as inviting other members or sharing or deleting files from the file manager. Workspace members will have access to the protocols that you are storing in their file manager. And they can use the common functionality to ask questions about those protocols. They can also make changes to those protocols. And there is a detailed log of all the implemented changes, so you can revert it if needed. Members of a workspace can also create their own protocols in the file manager, or take an existing protocol and make a fork or editable copy to optimize it further. And the platform, as I will show you in this movie, allows you to compare two versions of the protocol side by side. So you can easily see what are the optimizations between the two protocols. What are the differences between the two versions of the protocol? And even if a member of your workspace leaves, because let's say a student has graduated, the protocols will remain organized, up to date, and available in the file manager. You can also select to print or export any protocol as a PDF, or you can send it to Google Drive, Dropbox. So I'll show you in this example how you can export your protocol as a PDF. So you can print it and have a hard copy next to you at your bench while you run the experiment. You can also collaborate and share protocols beyond your workspace, either directly to people via email or by making them fully public, by publishing them. Publishing a protocol will assign to it a DOI and will allow anyone with an internet connection to search for it and to access it. A published protocol with an assigned DOI can also be referenced within an article, and this will be credit to the author's methodological work. The reference, as I mentioned before, will be linked to the protocol in protocols.io, so the reader will have access to the interactive step-by-step protocol, even if the article was published behind a paywall. And that's because all of our content is open access. Once the protocol is published, any reader can create a new fork or editable copy and modify it according to their needs. In that sense, all public protocols, because they are open access, are templates for further optimization. Now, the platform will link any forked protocol to the original one. And in this way, both authors of the protocol and optimizers will maintain and earn credit. For example, this is a protocol that is a modified version of an original protocol created by somebody else. The platform tells us that the protocol that you are seeing was forked from another protocol, which you can access by following the link. Thus, all authors get credit for protocol creation and for protocol optimization, and the reader has access to the history of changes and evolution of the protocol. Another way to share your protocols and to increase your credit for method development work is to send the protocols for peer review as a standalone methodological papers to Biotechniques, Nature Cell Biology, Nature Protocols, BMC Methods, Gigabyte, Lab Animal, or PLOS ONE. What you see on the screen is an example of a protocol in the platform and the tab that says peer review options, where you can see all the journals that take protocols from the platform. And this should increase the visibility of the protocol and increase your credit. Now, going back to the workspace, you can create multiple workspaces in your account depending on your research and teaching needs. You can create workspaces for different research projects or to teach different courses. Each workspace can have different numbers and contain different protocols and documents, giving you great flexibility for organization. Now, if you want to share protocols beyond your workspace, you can do that by using the share functionality. So what you see now, it's my account in protocols.io. You can see to the left all the workspaces to which I belong, and each of them has a different file manager storing different folders and different protocols. But this is my own personal workspace. If I want to share any protocol, any private protocol with specific colleagues that are not part of my workspace, I can just select the protocol that I want to share, click the share button, and then add colleagues to this protocol by typing their email address. Once I add colleagues, I will need to save the changes, and I can tailor the permission that those colleagues would have with this protocol. In this example, I added 3 colleagues just to this protocol, not to my workspace, just this protocol, and Lenny, Nastya, and Emma can both view and edit the protocol. However, I can change at any point the permission of Nastya, for example, and just allow her to view, not to edit. And now I can save the changes. And this is how sharing beyond the workspace works. Now, in the last part of my presentation, I will do just a very short demo about how to bring to the platform existing protocols that you might already have in a different electronic format, like a Word document or a PDF. So I'm going to minimize my screen. I'm going to go back to my file manager. I'm going to open this folder, which only has one document. And you can see here my hard drive that contains some protocols in different formats. So I have a PDF, I have a Word document, I have a text file. I can take these protocols, and the easiest way for me to centralize these protocols in protocols.io is just to drag and drop them. And now the protocols have been transferred to protocols.io. I'm going to reload the screen. While it does it, I'm just going to open one of these protocols for you to see. Right, so this is the PDF version of the protocol. It has a title, an abstract, and different sections with different steps. This is a PDF, and this is a Word document. Same thing. Now, the protocols have been centralized in the platform. However, and unfortunately, because these are documents in their original format, that is PDF or Word, they are not publishable. So I have to create a protocol with the editor for me to be able to publish the protocol. The easiest way for you to transform any of these existing protocols into a publishable protocol is to select the protocol, and we have an AI-based tool that will transform your protocol into an editor-based protocol. So I select the Word document or the PDF that I want to convert. I create a new protocol from this file using AI. It is working. And now the protocol has been created. You might remember how the Word document looked like. Now, if I view the protocol that I created with the importer, this is how the protocol will look like. The sections were created, the steps were parsed, the title was added, the abstract was added, and now I can publish my protocol. So this is the last part of the presentation. But before we reach the section question, I want to share with you that we can do this work for you. So we can import the protocol for you. And this service is free to members of institutions that are partners of protocols.io. To send us your protocols, you have to go to protocols.io. We enter protocols and upload your file. However, if you are not member of a partner institution, this service comes at a cost. So in summary, I hope to have provided enough information to persuade you that by practicing open science and open methods with protocols.io, you can stay organized, collaborate efficiently, save time, increase your impact, and get credit for your method development work. And with that, before taking some questions, I will very much appreciate if you can complete this survey about the presentation that I just gave. That will help me improve future webinars. So either you can scan the QR code with your phone, or you can follow this link, which I'm gonna add to the chat if I can copy it. Sorry about that. I'm gonna paste the link in the chat for you to please complete the survey. And with that, I will be happy to take any questions. I will stop the recording just in case somebody wants to ask a question of the record.